Assalamualaikum and good evening everyone. My name is Farzad Farzad. ID number is MA114 and I am from Group 7. Today our group will be presenting to all of you about our group project, that is Sultan Salahuddin Abdul Aziz Power Station. And we go through to my part. I will explain to you about the background of this power station. Okay, this power station called Sultan Salahuddin Abdul Aziz Power Station, or others name is Kapar Station. Kapar Station is the first coal-fired power plant and the second largest thermal power plant in Malaysia, and it started operating in March 1987 and it's operate until now. Okay, the company involved in this power plant is, there is two company. There is the Tenaga Nasional Berhad, also we call as TNB, and the second one is Malkoh Berhad. And you know that TNB has the largest holding names. There is 16% of share, and the Malkoh Berhad is only 40% of share. And the specialized of this power plant is, there is only one in Malaysia that using the triple fuel firing capability. The triple fuel is gas, oil and coal. This power station have 4 generating facilities that's called as GF1, GF2, GF3 and GF4. And each of the GF1, 2 and 3 has a boiler and a steam turbine. And for the GF4, there is have 2 units of gas turbine. That's why this power plant can generate a lot of electricity.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilmi bin Zulkifli. I am from Group 7 in Thermodynamics. Okay. Today I will tell you about the information of Sultan Abdul Aziz power plant. Okay. First of all, the power output that Sultan Abdul Aziz has produced is 2,420 megawatt. It has 1,600 megawatt coal-fired, 2 units of each 300 megawatt fired by natural gas, and also 2 units of each 110 megawatt fired by natural gas and distilled fuel. The primary fuel that this power plant use is coal, and the secondary is gas. The power consumed by pump, fans and auxiliary device around 7.5% of gross generation. Hence power consumed is about, overall is 700 megawatt. Thermal efficiency recorded is around 35 to 38%. Next, heat rejection at condenser is around 1300 megawatt. Heat is transferred from the coil to the air, which is then rejected to the outside. So it has heat rejection around to 23.2%. Lastly, the rate entropy of generation. A reversible adiabatic process is anisotropic, and a substance will have the same entropy values at inlet and outlet. Engineering systems such as pumps, turbines, nozzles and diffuser are adiabatic operation, and performance of them will be high when the irreversibilities such as friction produced in the process is reduced and hence operated under isentropic condition. Isentropic efficiency of a turbine at steady state is defined as the ratio of the actual work output of the turbine to the work output of isentropic operation, with the formula this. So that's all from me. Thank you.
Okay, for the questions, how much efficiency of the plant can be improved? Explain and write your calculations. Okay, so energy efficiency can be improved by keeping excess air to a minimum for combustion, complete use of the heat integration system, regular control for steam leaks and fouling of exchangers, operating continuously at full load capacity will improve efficiency, use higher coal grades because it allows greater efficiency because it contains less ash and humidity, use natural gas because it is the best choice, and the last point is colder cooling water, cooler air temperature, achieves higher efficiency as it will reduce the condenser pressure, resulting in more work extraction from steam. That's all.
Hi and Assalamualaikum. My name is Amir Adlan bin Arif Fadilah and my matric number is MA19124. For my part of the presentation, I will be explaining about how much of the following fuel is required to be used in this plant to have the same net power output, which is 2420 megawatts. The first type of fuel is coal. So for coal is a combustible black or brownish black sedimentary rock with a high amount of carbon and hydrocarbons. The required amount is 10 million tons. B, which is the second type of fuel, is natural gas. Natural gas is a naturally occurring hydrocarbon gas mixture consisting primarily of methane but commonly including varying amounts of other higher alkanes. For natural gas, the required amount of fuel is 68526,769.74 meter cube. The third type of fuel is diesel. Diesel fuel in general is any liquid fuel specifically designed for use in diesel engines. And for the required amount of diesel fuel is 60,500 liters. And last but not least is biodiesel. Biodiesel is a form of diesel fuel derived from plants or animals and consisting of long-chain fatty acid esters. And for the required amount is 65,941.873 liters. That is all the required amounts of the following fuel, which will have the same net power output, which is 2420 megawatt.
Assalamualaikum. My name is Muhammad Hazarul. My ID is MA19110. My part is the conclusion. Now I will tell about the conclusion. In conclusion, we have learned about the thermodynamics, a branch of physics, in the study of the relationship between heat, temperature, energy and work properties. The notion of entropy and the internal energy formula are central to that relationship and to the law of thermodynamics. The internal energy formula, or the first law of thermodynamics, states that with the interaction of heat, work and internal energy can be converted from one form to another, but cannot be created or destroyed. Thermodynamics entropy describes the measure of the thermal energy of a system per unit of temperature that is unavailable for useful works. For this project, we had gained many knowledge about power plants in Malaysia. This project to ensure our understanding about the power plant. We also learn about how to calculate efficiency, which is a great factor for the future power plant development. That's all from me. Thank you.